One of these life hacks has already sent someone to the emergency room. Today, we're breaking down 6 viral videos and counting exactly how many ways these internet geniuses found to injure you or scam you. First up, a universal cutting disc made from sheet metal and a centering ring from an old wheel. Cuts particle board, keyboards, tires with steel cord. Free and brilliant? Oh, absolutely not. 3 fatal flaws. All 3 lead straight to the ER. Flaw 1, the mounting. An angle grinder spins at 10,000 to 12,000 RPM. Edge speed around 175 miles per hour. The guy mounts his centering ring with superglue. Superglue. Superglue fails at 175 degrees Fahrenheit. Cutting rubber gets the disc up to several hundred. The moment that glue softens, the disc loses center, catches in the material, and the tool rips out of your hands. What you see in the video is a conveniently ended clip cut before the inevitable. Flaw 2, the teeth. Raw steel, zero heat treatment. Those notches leave sharp corners, perfect stress concentrators. Then the guy bends the teeth with pliers, manually introducing micro cracks. At 175 miles per hour, one of those cracked teeth catches a steel cord, snaps along the fracture line, and becomes a projectile. Congratulations, you just built a homemade fragmentation device. And last, fabric work gloves. The grinder does 180 rotations per second. One loose thread on one of those teeth. I think you can finish that thought yourself. The right call? Stop messing around and buy a real disc. A carbide multi-wheel, no teeth, no glue, factory balanced. Angle grinders don't forgive mistakes.
All fingers still attached? Good. You'll need them for the next one. This time from the world of automotive chemistry. We're looking at a video with, wait for it, almost 10 million views. The claim? Rub your windshield with an apple, water beads right off, like a premium hydrophobic coating. Throw away your wipers forever. And the comments? Oh, the comments. Thanks, it works. Amazing, definitely trying this. Why are car manufacturers hiding this? What is going on inside these people's heads? Here's the chemistry. An apple is water, sugars, acid, and pectin. Pectin attracts moisture. It makes water spread into a film, not bead off. You've done the exact opposite of what you wanted. What actually happens? You leave a sticky matrix of sugar and acid on the glass, a perfect trap for road grime. Your wipers drag through it. The rubber edge wears out. The wiper motor takes the extra load. It's like smearing jam on your glasses so you can see better. The right way? 3 steps. 1. Clay bar with soapy lubricant pulls out tar and embedded contamination that a regular wash won't touch. 2. Wipe down with isopropyl alcohol. Dirty surface means nothing bonds properly. 3. Apply a fluoropolymer or silicon dioxide hydrophobic coating. No waxes, no silicones. You'll end up with squeaky wipers and that milky haze from headlights at night. Buy the apple. It belongs in a pie, not on your car. The last one could wreck your windshield. This one could drop something heavy on your skull. This build actually looks impressive. The guy clearly knows how to use his hands. And that right there is exactly what makes it dangerous. Competent-looking builds are the ones that send people to the hospital. Setup: a ceiling-mounted winch built from a burned-out angle grinder gearbox, a motorcycle chain, and a cordless drill. In the video, it lifts a big empty case. Looks great. Here's why you can't trust it with anything that actually matters. Problem 1. The gearbox. An angle grinder uses a spiral bevel gear, fine teeth designed for speed, not for load. Put real weight on it, and those teeth shatter. Problem 2, and this one will get you killed. A bevel gear is fully reversible, efficiency close to 90% in both directions. This is not a worm drive. In practice, you lift a heavy load, release the drill trigger, gravity immediately takes over. The load drops.
The guy in the video lifts an empty case. That's why it works. Load it for real, and it's a different story. Problem 3. Welding a hardened motorcycle sprocket to raw steel tube with a basic electrode. Under shock load, that weld will let go. Not if, when. Want to actually build a safe DIY electric hoist? Forget the salvaged gearbox. Buy the cheapest factory manual drum winch rated for 1,000 pounds. It already has a proper drum, correct axles, and a steel ratchet mechanism. Remove the crank handle, attach a corded drill through a socket adapter. Don't gamble with overhead loads. If the last build could drop something on your head, this one will slowly poison you in your sleep. Some guy decided to heat a room with the power output of a nightlight. He takes a gray PVC drain pipe, plastic drain pipe, and wraps 200 meters of carbon heating cable around it, coil by coil, tight as a boa constrictor. His claim: draws 9 watts, heats like a furnace. His temperature sensor melted on camera. I'll wait while you reread that. Check the power meter, 8.9 watts. That part is actually true, because 200 meters of carbon cable with serious resistance gives you a resistor in the thousands of ohms. Current isn't flowing through it, it's crawling. 9 watts is one LED bulb. Trying to heat a room with it is like trying to boil a bucket of water with a match. One match. Then the materials. PVC drain pipe as the heater core. PVC starts breaking down above 140 degrees Fahrenheit and off-gases chemical byproducts you really don't want in your lungs, especially while you sleep. And the tight coil winding? The manual for heating cable says explicitly, do not coil tightly. The adjacent wires overheat each other. Here's the thing though, the original vertical convector idea is actually solid. Here's how to do it without burning the place down. Galvanized ventilation duct, not PVC. Wrap it first with a full layer of Kapton tape or fiberglass electrical tape. Cut cable into 32 to 40-foot sections, not 1/650-foot sausage. Wire them in parallel through crimp connectors. Do not twist or solder carbon to copper. Thermostat for overheat protection, non-negotiable. 3 sections at that length, honest 400 watts. Duct fan inside. That heats a room. The original? That heats the content creator's view count. While our properly built heater warms the garage, let's talk about something smaller but just as aggravating. A broken gear tooth. Classic. Equipment down over a 50-cent part. Enter superglue. The guy embeds a wire staple into the broken tooth, makes a paraffin mold, pours in superglue mixed with graphite. The paraffin mold trick is genuinely clever. Superglue doesn't stick to wax. Points for that. Everything else? Let's go. Gears are usually polyacetal or nylon, waxy, chemically inert plastics. Superglue has essentially no mechanical adhesion to either. That beautiful repair is held together by one bent wire staple and pure optimism. The staple itself, he melts it in with a soldering iron running at around 570 degrees Fahrenheit. Polyacetal doesn't just soften at that temperature, it locally decomposes. He destroyed the plastic around his own reinforcement before he even got started. And cured superglue is hard and brittle. Gears need to flex slightly under load. That repaired tooth won't flex, it'll shatter on the first hard start, or it'll take out the neighboring gear on its way out. How to actually fix it? Skip the soldering iron. Cut a dovetail slot, drill small anchor holes, use machine screws or scored wire for reinforcement, bond with 2-part metal-filled epoxy. Still won't chemically bond to the plastic, but it won't shatter either. Honestly, even that buys you time, not a permanent fix. The real answer is a new part, or a 3D printed copy in nylon or composite. Some things just need to be replaced. And finally, the Holy Grail of internet inventors. Perpetual motion, free energy, no electric bill ever again. Let's go through this carefully. The claim, a standard 220-volt AC induction motor can be run from a 12-volt car battery, then looped with a generator to feed itself indefinitely. Act 1. Magnetizing the rotor. He heats it with a torch, runs current from a battery through it, and declares it a permanent magnet. Oh, come on. Electrical-grade steel is a soft magnetic material. It holds magnetism only while an external field is present. Remove the current, the magnetic properties vanish. Heating it does nothing. That's like trying to harden Play-Doh by putting it in the oven. The washer in the video sticks to the rotor because it's a neodymium magnet. It would stick to any random piece of iron off the floor, heated or not. Act 2. He applies 12 volts DC to windings rated for 220 volts AC. DC creates a static field. The rotor locks to a pole and sits there. To spin an induction motor, you need a rotating magnetic field, and that only comes from AC. The grand finale: motor drives generator, generator feeds motor. Infinite free energy. Except the law of conservation of energy didn't get repealed last week. Friction, heat, resistance, it all consumes the system's energy. The whole thing coasts to a stop in seconds. You can't make a river flow uphill. You can't make an apple work like a ceramic nanocoating. And you can't get energy from nowhere. Drop a comment or find me on Telegram. Tell me what to tear apart next. Like, subscribe, don't miss the next one. Keep your fingers, use your brain. See you in the next teardown.